In this video, we're just going to recall some things about limits. To begin with, looking at a graph, we're going to start with the spot -5. So -5 is right here. So as we approach -5 from the positive side, so meaning we're coming towards -5 from the positive side, what y value are we approaching? We're approaching -1. As we approach -5 from the negative side, so we're coming up along the negative side, what y value are we approaching? -2. Please remember, you do not have to touch. It doesn't have to be a closed circle. It doesn't matter. It's just what y value is it approaching. So then I ask, what is the limit at -5? And of course the answer is it does not exist. Because for a limit to exist, it must be approaching the same y value from both sides. And it's not. It's approaching -2 from one and -1 from the other. Next, let's go up here to 0. Approaching 0 from the positive side. So we're approaching 0 from the positive side. We're approaching a y value of 2. Next, approaching 0 from the negative side. So we're coming along towards 0 from the negative side. We're approaching a y value of 4. So once again, the limit does not exist because we are not approaching the same y value from both sides. Alright, next, the limit as x moves to infinity. So this is basically saying what is the horizontal asymptote, because as this function zooms off towards infinity, what y value is it hanging on? It appears to be hanging right on to 2. Okay. Next, let's look at the limit at -2. Well, you notice that it's coming along, approaching -2 from both sides. It's approaching a y value of +2. A lot of people look and say, yeah, but it's defined up here. It doesn't matter. A limit is what y value it's approaching. It is approaching a y value of 2. The fact that there's a hole here and it's defined, the function's defined up here, means it's not continuous. But that doesn't have to do with the limit. The limit is just what is it approaching. Finally, we'll do the limit as x approaches 2. Spiking up as an asymptote. You could either say the limit does not exist, or if you really wanted to be good, you'd say, oh, the limit looks like it's infinity. Infinity because it's moving towards positive infinity on both sides. If instead of looking like this, the graph did something like this, you would definitely say the limit doesn't exist, because then it's approaching negative infinity on one side and positive infinity on the other. But at least in our particular graph, it's approaching the same value from both sides. Next, some basic limit stuff. Remember, you should always, first thing, just try and plug in the value. So if I just plug in -2, let's see what happens. 3 multiplied by -2 squared, so 3 multiplied by 4, minus 2 multiplied by -2 plus 1. So we get 12, plus 4 is 16, plus 1 is 17. The next example, it says the limit is as x approaches 5 of 4. Well, that's just 4. There's nothing to plug in. And remember, this would just be a horizontal line. So it's just going along, and yeah, it doesn't matter what it is, what x value. It's always going to be 4. Next, plugging in -3 here, we've got -3 cubed minus 2, which is -27, minus 2 is -29. Always try and plug it in first. And we call that just substitution. Next, we try and plug in here, we get, in the next one, plugging in 8, we get 8 squared minus 64. Well, that's 0. That's not the end of the world. But then on the bottom, we also get 0. Well, remember, the cases where we get 0 over 0 0 over 0, is where we can invoke L'Hopital's rule. L'Hopital's rule says that we can take the derivative of the top and bottom and try and take the limit again. So the derivative of z squared minus 64 is 2z. The derivative of z minus 8 is just z. No, I'm sorry, it's just 1. So we try and plug in 8 again. 2 times 8 is 16. Next problem, let's try and plug in 1/4. Well, 4 times 1/4 is 1, minus 1 is 0, but it's not the end of the world. Okay. But 1/4 squared is 1/16. So 1 minus 1/16 times 1/16 is also 0. So once again, we get to use L'Hopital's rule. Remember, L'Hopital is for 0 over 0. 0 over a number is the limit is 0. A number divided by 0, the limit does not exist. L'Hopital is for an indeterminate form. And there are other indeterminate forms, but the biggest one we're focusing on right now is 0 divided by 0. So the derivative of the top is just 4. The derivative of the bottom is negative 32t. So now we plug in 1/4. We're going to get 4 on top. Negative 32 multiplied by 1/4 is negative 8. So the limit is negative 1/2. Okay. Last one. Plugging this in, negative 2 squared is 4. Minus 10 is negative 6. Plus 6 is 0. Down here, negative 2 squared is 4. Minus 4 is 0. So once again, we've got 0 over 0. We invoke L'Hopital. So limit as x approaches negative 2. Derivative on top is 2x plus 5. Derivative on the bottom is 2x. Now we plug in negative 2. So negative 4 plus 5 is 1. Negative 2 times 2 is negative 4. So there's our limit.